Yes, I'm Ernest. Welcome to our channel of Sciences and Mathematics. Today we're going to look at a concept in vector calculus, and that is the concept of gradient, divergence, and curls. And these specific concepts are going to assist us to describe some of the fields that we encounter in physics, especially the gravitational and electromagnetic fields. And they also find some wide applications, like trying to describe some of the control systems that we use, fluid dynamics, and maybe in structural analysis. So we have already discussed some of the concepts in vector differentiation and vector integration. And for today, we're going to look at some of the identities that we need to know in order for us to describe these fields effectively. So without further ado, thank you and welcome. Now, as I've said, today's topic is going to be basically the concept of gradient, divergence, and curls. And now, before we proceed, I'd like to encourage us guys to go to YouTube and try to subscribe to our channel of Sciences and Mathematics. Because as we're proceeding in discussing some of these topics, some of them will also need to be complemented by other areas that we have already discussed. So for those ones who have already subscribed, of course, I've already said that I usually put a link of the videos or a link of our playlist in the videos, whereby we can be able to select and be able to view other videos which are related to this. And that one will assist us in enhancing our deeper understanding of the concept. So for today, we're going to look at this concept of gradient, divergence, and curls by trying to describe a very important concept that, of course, we have discussed from the concept of vector differentiation. Now, suppose we have a point x, y, z in a rectangular coordinate system, and there corresponds a vector which is represented as a vector A. We can be able to represent A in terms of this coordinate system by giving it x, y, z, which are the points in this specific coordinate system. Now, this specific representation is known as a vector function of x, y, z, and we call this vector function a vector field, which basically implies a vector field. Now, using the same analogy, we had looked at the concept of differentiation and talked about a vector function of a scalar variable, but in this case that corresponds to maybe a vector A. But in this case, we are using the points of the coordinate system, that is x, y, and z, that has got a corresponding vector A, and therefore we can be able to describe the relationship that I've illustrated on the board as a vector function of x, y, z, basically which we are referring to the concept of a vector field. Now, I've talked about one of the applications of vector calculus is describing electrostatics and the fluid dynamics, which entails the concept of fields, of course. Now, in this case, we are going to also consider maybe a scalar representation of this particular function by using a different maybe aspect from the vector A. Now, suppose we have another one that we can be able to represent as x, that has a relationship with the coordinate system x, y, z. Therefore, we can be able to represent a scalar function using this specific representation. And this is going to be referred to as a scalar field. And therefore, for the two particular aspects that we are talking about of a point of a rectangular coordinate system, we can be able to represent it using a vector function of this one and a scalar function that can be represented as phi x, y, z. Now, sometimes in representing some of the important identities which we are going to apply later, it is convenient to use a vector differentiation operator or a vector differential operator that we're going to represent shortly. And this vector differential operator is referred to as del, and we're going to encounter it maybe in some of the areas that we may need to do differentiation. Now this del is symbolized using this inverted triangle, and this symbol basically represents this specific del y plus this is k dz. So basically this representation that is I've given on the board implies the concept of a del, and therefore del can be represented as this specific representation. Now this is convenient, as I've said, in trying to represent or maybe try to show important quantities, and these are the specific quantities that we have talked about of a gradient, divergence, and the curl. So from this particular specific point of a rectangular coordinate system that corresponds to a vector, which of course we have called as a vector function and of A and a scalar function of phi, we can be able to represent these three important identities by trying, or the quantities by trying to use the concept of del, and that is the concept of gradient, divergence, and curls. Now we're going to look at each of them and how they can be represented by using this important maybe representation known as del, that we have called the vector differential operator. Now for the concept of a gradient, which is going to form our first one, a gradient can be given as del phi, and this basically can be represented as xi plus yj plus z k phi. So basically this one represents what we call a gradient, and generally this one now can be expanded to form a general equation for this gradient, which is given as phi of x plus j y phi of y plus e phi z, and this is basically the last one. This is the k component. Of course, in the presentation of these vectors means we have given the dimension for x, y, and z. I'm generally going to give them the last ones, but remember these are vectors. So therefore, this is a vector quantity that is going to be given as the gradient of phi. So this vector quantity represents the gradient. This is the gradient of phi, known as grad phi. So in case we represent in any of our vector, maybe under the concept of vector analysis or vector calculus, grad phi, and this basically implies this specific representation that represents the gradient of this specific quantity that we've referred. So basically this is how we can be able to represent a gradient. Now I'm going to illustrate the remaining two so that we can be able to demonstrate others using examples on how we can be able to represent these three important quantities. So that is the first one for representing the gradient. Now the second one, we're going to look at the way in which the divergence can be represented. So in that case, the divergence, which is going to form our number 2, is given as this differential vector differential operator dot A. Now from the dot product of vectors, you can be able to infer some of the information that we have already learned in this case. Now this is going to be represented as xi plus ey plus zk, and then I'm just going to do that because of space. This is a continuation for the product of A, as we said, is a vector that is represented by its three components for the x, y, z. So A1, A2, A3. So the sum vector of this one can be represented as I, j, and k. So it's a dot product between this del and A, which is represented as such. So the overall equation for this one for representation of a divergence can be given as del A1 over del x plus del A2. This is y plus, so this is z, and this is a z component which is given for 3. So remember the multiplication of vectors. We talked about the concept of I, j, k, which basically gives identity. The identity, we talked about the identity vector, and for the dot product, I hope we can be able to remember why the representations for this have disappeared. So basically this is going to give a product for a scalar product, which basically we refer to as a divergence of this vector A. So this is a divergence of A, which is going to be given an initial or maybe a representation of a div A. So in any case, we write this one, div A will represent a divergence, which is a product of those two del and the vector A, which basically gives us this equation that we have indicated on the board. Now that is for the second one, for divergence, and the last one that we're going to look at is the concept of a curl, and try to see the difference between the gradient, the divergence, and curl. So basically I'm going to also use this representation. So number 3, we are going to look at the concept of curl. Now for curl is given as del cross A, and we talked about the components of A. So therefore we can be able to expand that one. Now this is a del A, and write it as I ex plus ey j plus ez k cross the components of A to, this is I, j, k, and for the cross product of that one, we're going to use the I, j, k. This one will form our, from the matrix representation of that, y, z, and this is A1, A2, A3. So this is going to give us A3, 1. So we just do a cross multiplication for this. So the product between this one and this one is going to give us the first one minus this. So for the I component, we're going to have A2 by dz. This is for I plus. Now for the z, it's normally the coefficient is preceded by a negative sign, so it's going to be have an arrangement. But basically, it is the difference between the cross of this one and this one. So it's going to give us A1 z minus A3 x j, and the last one is going to be a2 ex minus a1 ey. So I'm just trying to do a confirmation to ensure that I write the correct component. So in this case, this is known as the curl of A, and is given an initial as, maybe given a representation as the curl of A. So therefore, if we mention the concept of a curl of A, it's going to imply the cross of this specific del and A. Now, from the above three concepts that we have discussed, we're going to mention two important identities apart from the curl, the gradient curl and divergence, which we are going to use in applying, in finding solutions to some of the challenges that we may be able to share as problems in our discussions. So the first one of those important identities is the divergence of curl A, which is going to be represented as del dot del cross A, which is going to be 0. So from other representations, we have of course learned about the concept of different identities, especially in trigonometry, and as from the concept of this divergence, curls and gradient, we have one of the identities that's known as curl del A, which is given as this one, which is equivalent to 0. So the number 2 is the curl grad phi, which is given as del cross del phi, which will be equivalent to 0. So that's just for our application. In case we come across them, then we'll be able to remember that it is an identity from the vector differentiation that we mentioned, which is referred to as the div curl A, curl grad phi. So in this case, of course, we are going to use specific examples in our preceding, or maybe of our next videos, in trying to find out where we can be able to apply the concept that we've already discussed. That is for gradient, divergence, and curls. So in any case, if we are talking about maybe a gravitational field, fluid dynamics, solar electromagnetism, these particular concepts that we have talked are going to be very important for us to try and understand those concepts. Of course, we are going to get used to them in trying to do some of the sample questions for 1 or 2 in our next videos, as I've said. So for today, I hope that this is going to assist us in trying to find maybe the gradient, the curl, and the divergence of some of the functions that we may be given. And it's going to assist us in trying to gain a skill or 2 in vector calculus. So that is it for today, guys. Bye. God bless.